Good afternoon to all. The webinar titled Building Wetland Resilience, Nature's Ally in Climate Change Mitigation is organized by Puducherry Climate Change Center. As we see the climate changing, we often look for expensive high-tech solutions. But some of our best helpers are already right here is our wetlands. Often called the Earth's kidneys, these areas are amazing in cleaning up water, storing carbon, and protecting us floods. Today we are here to talk about how we can take better care of these natural protectors. To set the tone for today's session and formally welcome our gathering, I would like to invite Sri K. Kalamegam, Environmental Engineer from Department of Science, Technology and Environment, to deliver the opening remarks.
Respected Speaker, esteemed officials, distinguished participants, ladies and gentlemen, a very good evening to all of you. On behalf of the Puducherry Climate Change Cell and the Department of Science, Technology and Environment, I extend a warm and cordial welcome to everyone joining us today for this session under the Climate Change webinar series. At the outset, it is my privilege to warmly welcome our distinguished speaker, Dr. Ranjit K.R., Scientist B in the Center for Water Resource Development and Management, Kozhikode, who has kindly consented to share his expertise with us on the topic Building Wetland Resilience, Nature's Ally in Climate Change Mitigation. We are grateful to you, sir, for sparing your valuable time and for agreeing to guide us with your rich experience in wetland science and water resource management. Climate change poses a complex and evolving challenge for the Union Territory of Puducherry, particularly given our coastal setting, riverine systems, wetlands, lagoons, estuaries, and the low-lying areas. Increasing temperatures, erratic rainfall, sea level rise, salinity intrusion, urban flooding, and degradation of natural ecosystems are already impacting our environment, livelihoods, and water security. In this context, wetlands assume critical importance. They act as natural buffers against flood and storm surges, regulate hydrological cycles, support biodiversity, sequester carbon, and sustain fisheries and livelihoods. However, wetlands are among the most threatened ecosystems due to land use change, pollution, encroachments, and unsustainable development pressures. We at Puducherry Climate Change Cell have been actively working on strengthening climate action through policy support, awareness programs, capacity building, and integration of nature-based solutions into planning and governance. Promoting wetland conservation and resilience is central to our efforts under the State Action Plan on Climate Change and aligns with the national priorities and global commitments. Today's webinar is therefore both timely and relevant. It aims to deepen our understanding of how resilient wetlands can serve as powerful allies in climate change mitigation and adaptation, and how scientific knowledge can inform better policy, planning, and community action in Puducherry and similar regions. I am confident that the insights shared by Dr. Ranjit will greatly enrich our perspectives and help us move towards more sustainable, climate resilient, and ecosystem-based approaches to environment management. Once again, I extend a warm welcome to our speaker and all the participants joining us through Google Meet and YouTube Live. I encourage everyone to actively engage in the session and make the most of this valuable learning opportunity. With these words, I have a great pleasure in formally welcoming you all to this webinar. Thank you.
Thank you, sir. Moving forward, I would like to introduce our today's webinar speaker. Dr. Ranjit is currently working as Scientist B in the Ecology and Environment Research Group at Kerala State Council for Science, Technology and Environment, Center for Water Resource Development and Management, Kozhikode. He holds a doctorate in aquatic chemistry from the School of Marine Sciences, Cochin University of Science and Technology, with his doctoral research focusing on hemodynamics and ecohydrology of tropical estuaries. Dr. Ranjit has more than 15 years of academic research and professional experience, spanning roles as assistant professor in marine chemistry, environmental expert with Ministry of Ministry of Environment, Forest and Climate Change, and BIA consultant. His research expertise covers wetland management, aquatic biogeochemistry, water quality monitoring, microplastics, nutrient dynamics, greenhouse gas emission from wetlands, and climate change impacts. He has led and contributed to several nationally significant projects as principal investigator, including greenhouse gas inventories from coastal wetlands, integrated wetland management plans for Ramsar sites, and long-term monitoring of critical freshwater and estuarine systems in Kerala. Dr. Ranjit has also published extensively in high impact international journals and edited volumes, particularly in the areas of estuarine biogeochemistry, microplastics, and coastal sustainability. On this note, we warmly welcome Dr. Ranjit KR and invite him to begin his presentation.
Thank you for the nice introduction and also for the opportunity to be part of this important webinar series arranged by Puducherry Climate Change Cells. So shall we start with the presentation? More? Can you switch on the presentation?
Yes, sir. We'll be presenting the slides.
Okay, no problem. So I'll try to wind up in 45 minutes so that we can have a time for interaction also. Okay.
Slides are visible, sir.
Yeah. Can you remove that active screen from the? Yeah. Now it's more clear to me. So I can start with that. Before starting the presentation, I would like to introduce my institution, that is Center for Water Sources Development and Management, which is under Kerala State Council for Science, Technology and Environment, which is fully under Kerala State government, and we are actually the knowledge partners of Wetland Division of Ministry of Environment, Forest and Climate Change, as well as the primary knowledge partner of State Wetland Authority Kerala. We also serve as a secondary knowledge partners of Puducherry Wetland Department also, because I think for Puducherry the primary knowledge partner is SACO. So we also are closely working associated with SACON also for many of the activities related to the wetland management in South India especially. Starting with the first slides, please. So as this context is already being set, and there are a lot of introduction, there is a lot of important points were mentioned about the wetlands. I will start with the. Can you change to the slides now? Next slide. Yeah. So I always, because we do have a very good Wetland of India portal where most of the details that I'm going to discuss now is being available. So I request all of the researchers in this group to have a look at all the Wetlands of India portal, which is being nicely maintained by the Ministry of Environment, Forest and Climate Change Wetland Division. And we can see that in India, we have about 2 lakhs and 205 wetlands, which are having a size, means area greater than 2.25 hectares. And when we consider all the smaller wetlands also, that will come to more than 7.57 lakhs of wetlands. That is a huge number, which is covering around 15.3 million hectares, which comprises mostly about 4.98% of the geographical area of India. So that is a huge number when it comes to the wetlands in India. And we can say that from the figure, it is very clear that majority of the wetlands comes under the different classes that is being mentioned in this thing, that is lakes, human-made wetlands, river floodplains, marshes, oxbows, lakes, estuaries, and swamps. So these are the major classes of wetlands. And in the left side, left corner, we can see that the major wetlands types in India. We have majorly inland wetlands, inland natural and inland man-made wetlands, and as well as the marine or coastal natural and coastal man-made wetlands. So these are the major classes of wetlands that you can find in the Wetlands of India portal also. So next page. So whenever we say about wetlands, wetlands are actually the superheroes of nature. We can say that they are the major, even though they play a lot of ecological ecosystem services, the major one that is always being highlighted is they act as a carbon sink, because they have a very high capacity for the sequestration of carbon, which we can clearly see in this picture, and it is more than 5 times higher than the tropical rainforests, which are always postulated to be having a very high potential for carbon sequestration. And another important aspect of carbon sequestration capacity of wetlands is that they store the most of the carbon that is being sequestered from the atmosphere is getting stored in the underground, below ground water, as a below ground water mass, where you can see from the map itself that above ground water mass means the carbon biomass is very less compared to the one that is below the ground, because that will not become available to the ecosystem, will into the atmosphere for global warming and all things very less. So that is the major importance of this category. And we generally say that these wetlands are having a carbon sequestration capacity which is about 3 to 5 times higher than the tropical rainforest, but the carbon barrier rate is about 5 to 10 times higher than the tropical rainforest. So that's the significance of wetlands as a carbon sink, and the carbon sequestration potential is being very well documented everywhere. And apart from that, they serve as a biodiversity hotspots. They are the natural purpose for climate-related disasters, and they livelihood support is another important aspect of ecosystem services that wetlands provide to us, which has to be highlighted in a very good way. And next slide, please. So whenever we say about livelihood and other things, we always compare that with the sustainable development goals. So wetlands are vital for human well-being, economic growth, and climate action, and they have a significant contribution to all the 17 SDGs, making the conservation of wetlands, or the fund that is meant investments in wetlands, a very cost-effective one. So, and another important aspect is that whatever management action, whatever we do for the conservation of wetlands, that creates synergies about multiple SDGs and global conventions which are related to the wetland, not just wetland, but about biodiversity conservation or UNFCCC. All these conventions are directly related to wetland protection. So that means any investment in this has a cross synergical impact. And that's why wetlands, you can say that from the figure, it is being directly connected to all the 17. And next, please. And the one which I am going to discuss today is this particular slide, which will be discussed in detail, which is the SDG 13, urgent action to combat climate change and its impact. So how this wetland is important is like the figure itself shows that the below ground carbon biomass storage it's very high, more than the 643, as we see ton of carbon per hectare. If you this is an estimate for 1 meter below ground biomass. So that much of biomass is being stored in the wetlands compared to any other systems, and that's why wetlands soils are the reservoirs of more than 35% of world's organic carbon. So if we are going to manage and restore the wetland effectively, that is going to have a very good buffering system against its climate change and disaster risks and the greenhouse gas emission related things. So this is widely referred to as blue carbon ecosystem because coastal ecosystems such as mangroves, salt marshes, and seagrass, they, as I mentioned earlier, they have a very high capacity to sequester carbon, and also they bury carbon deeply, and which means long-term storage of carbon, which will not be which will be available for any kind of climate-related disasters in the immediate future. And that's why global commitments, so far more than 28 countries have included blue carbon emissions in their nationally determined contributions under UNFCCC. 59 countries recognize this ecosystem in national adaptation strategies also. And apart from that, we have peatlands, which are very high because they cover more than compared to wetlands, they cover very less area, but they have twice as much carbon as the forest, all the forests combined, and their degradation is going to release a large amount of greenhouse gases. So that means that we have a very important mission to conserve our peatlands, so that the carbon that is getting stored in the peatlands will not will not cause a high release of greenhouse gases in the atmosphere. And the restoration adaptation, because if you just like wetlands usually act as a sink of carbon, and when they are degraded or deweighted, they have a very high potential to get to release the carbon that is getting sequestered or are getting trapped inside this their soil system. That's why very important that we make restore and manage our wetlands very properly. Otherwise, it's like a bomb. We are sitting on a bomb wall. This thing, so that any time it can contribute to the large release of these greenhouse gases into the atmosphere. So next slide, please. So this is I request all of you to go through the global wetland outlook to 2025, which is being recently released, and that is categorically says that more about 7.98 trillion dollars are the contribution of these wetlands due to the ecosystem services that is being rendered by the wetlands, and that contributes to more than 7.5% of the global GDP. It's a very huge amount. And the another saddest thing is that more than 22% of the global wetlands have been lost since 1970s, and it is being estimated that the degradation rate or the degradation of wetlands are for 0.52% per year. That means 0.52% of the wetlands are being lost every year, which is higher for compared to any other ecosystems. And that is the irony in that even though wetlands are having the higher value per hectare, economical value per hectare, yet they are the most threatened and most destroyed species, as in the introductory remarks sir has mentioned. And the major drivers of this is the unsustainable agriculture practices and land use and cover changes and the infrastructure development, water abstraction, and the climate change effects like drought and other thing, and which is actually contributing, because as in the initial slides I mentioned that these wetlands are actually the superheroes which are high hotspots of biodiversity. So more than 40% of Earth's biodiversity is being rested in these wetlands, and that is a very dangerous situation if the wetlands are being lost in this fashion or at this pace. Next slide. So these are the you can see that direct drivers, basically habitat change, climate change, invasive species, overexploitation, and pollution. These are the 5 major categories of these wetlands degradation. And you can see in the left side is inland wetlands, coastal and marine, how these are being affected, and the intensity of this impact is also being highlighted in the right side, that the diagrams, the arrows, and we can see that if that means if we are not going to manage the wetland properly, it is going to be completely lost from this earth itself, because that much higher pace it is being degraded at this moment of time. Next. And the living planet report, that is I've given that the page of that. Please kindly go through the living planet report of the latest by WWF. It clearly says that 85% of declination is having happened in the living planet index because of the loss of these kind of wetland area and other things. So the bottom line is that there is an urgent need to scale up funding for wetlands, aligning finance with sustainability by investing in conservation, restoration, and wise use, while redirecting the harmful subsidies. Without major shift in this kind of financial flows, we cannot achieve the sustainability of wetland, which will finally contribute to the minimization or mitigation of the climate change, as per the what our conventions or our agreements that our country has, many countries have put forward as NDCs. So next slide. So in this aspect, this blue carbon, the concept of blue carbon is very important. How this blue carbon concept and how they can relate to climate change mitigation. So blue carbon is a coastal and we commonly say the coastal and marine ecosystems such as mangroves, forests, seagrass, and tidal marshes that capture a huge amount of carbon, and this is called actually the blue carbon. And these have a very high capacity for the as I mentioned, burial of this carbon into the soil, and that by preventing it to come to the atmosphere and changing or impacting the climate change. But when they are getting drained and destroyed, they emit a huge amount of greenhouse gases, which push us to the climate emergency, which is something that we have to address very, very significantly. And if you want to change, if you have to change the if we have any chance of meeting 1.5 degree of this wetland, that goal, that 1.5 degree increase, we have to limit that. Then we have to restore at least 50% of the degraded peatlands before 2030. So that is the only way out for us to achieve this kind of the ambitious climate change goals that all the countries have set. Next, I'll explain the blue carbon in details also. So if wets and degrade, because as I mentioned earlier, these wetlands usually act as a sink of these greenhouse gases. But the main problem is that because of this change in the climate, the warming of temperature, changing in the climate patterns like rainfall and everything, that has resulted in the methane feedback, and that's what is happening. You can see from here the world largest wetland system are now acting as a very high emitters of the methane and other greenhouse gases. So that is the main problem. That balance between the wetlands being a sink of, or acting as a sink of these greenhouse gases is slightly shifting towards the detrimental direction, that is towards the wetlands are starting to act as the major sources of greenhouse gases, especially like methane and all. So that is a very, very warning signal that we have to see, and we have to it's a indication that we must manage our wetlands very sustainably, very scientifically, otherwise it will act as the major source of the greenhouse gases. So next slide is also a complementary to the next slide, please. It is also a complementary to that, where another accelerating atmospheric methane associated feedback emissions from large peat-rich wetlands is also happening. You can see that the Copernicus the monitoring systems and all are in place, which will give you a direct reading of the emission of the emission that is happening from the largest wetlands of different regions of the globe. Next one. And NOAA have recently introduced a greenhouse gas index. That is one they have made 1990 as a base scale of 1, and it has crossed 1.5 in 2023. That means around 50% increase in the greenhouse gases flux happened during the last 20 from 1990 to 2023. That means in a span of 30 years, this much 51% of increase in the greenhouse gases has been taken place, and that's why wetlands in significance is increasing day by day. But we can from these literature that I've mentioned here, we can see that the coastal when you see the coastal vegetation and the estuaries, all these combinedly act as a greenhouse gases. But most of the water aquatic system, that water phase basically are contributing towards the greenhouse gases emission also. This is something that we have to ponder on. We have to discuss more and deliberate on the things that now the wetlands are being increasingly becoming the source of greenhouse gases, especially like methane. So that is mentioned in the other literature that I mentioned, recent intensification of wetland methane feedback. So next, please. So in that aspect, we have to define what is blue carbon. Blue carbon, you can see that the blue carbon is referred to the carbon captured by marine organism and stored in the living and dead biomass, as well as in the organic compounds in sediments. So blue carbon, the concept of blue carbon, you can see that the publication that I've mentioned here, they have categorized put that IPCC has put that it is amenable to management. The carbon that is amenable to management, that means a management aspect has also been put forward, which actually has a positive impact effect on the climate mitigation and meet the following 3 criteria. So they have put forward 3 criteria, which means they should have a positive impact on climate change mitigation. So if you want to term it as a blue carbon, it has to meet 3 criteria. The criteria 1, that is reduce the BC measures reduce anthropogenically caused emissions and positively affect the net carbon capture and storage in marine ecosystem in a time frame of several decades. As I said, when the burial should be for longer periods, not that it's a short time capturing, because it should have a significantly higher span of carbon storage is required, so that it has a positive impact on the climate protection. Second thing is that it must be accompanied with an appropriate monitoring of carbon fluxes. So the blue carbon measures must accompanied by a continuous monitoring to demonstrate significant carbon uptake, carbon storage in the habitat, as well as the influence of human activities on carbon sequestration. So this should be a monitoring aspect or the measurable aspect into that also. So to ensure that BC measures to deliver additional benefits for biodiversity and society, the criteria is state that BC measures must be aligned with the concept of NBS, nature-based solutions. So that is very important. So that is how these IPCC have defined BC, blue carbon. So it's very important. Whenever we have been actually advocating for blue carbon for many times, but the actual definition of blue carbon, as per this is very important when it comes to IPCC perspective or carbon mitigation or carbon credit perspective. So very important how what is the definition of blue carbon in this aspect. Next one. So this in this they have I request everyone to go through this important that report, and in that they have criteria for blue carbon, whether this mangrove, seagrass, tidal or other microalgae or coral reef, the system, whether they have the potential, how much potential they have, it is being estimated, and we can see that they have the mangroves have very important contribution, and sea gas meadows also have very significant contribution into that thing. And the another important aspect is that the greenhouse gas release and the dissolved carbon fluxes are actually large, as we have seen in the case of in the previous slides. The methane feedback from the wetlands are being very high, and it cannot be underestimated or it cannot be neglected. So that aspect has to be a part of this carbon budgeting system, and it is now being insignificantly covered by the existing data sets. So, and methane nitrous oxide emission from these blue carbon emission, these things are not fully understood and needs a further research. That is something that I want to stress you. These are being not fully understood, and it needs more research in these aspects. Next one. As there are insufficient data, and in that book they have clearly defined the role of blue carbon in international policies. So sustainable management, conservation and enhancement of oceans, coastal and marine systems are part of the commitments included under Article 4 of UNFCCC. So along with the ecosystem, terrestrial ecosystems, coastal, marine, and ocean systems are referred to as sinks and reservoirs controlled by this Montreal Protocol. And among these Kyoto and Paris Agreement, only Paris Agreement has explicitly mentioned these oceans. So there is a lack of ambiguity about, or a lack of clarity about the role of these blue carbon sequestration and everything in the policy, international policy, how it is transformed into the international policy. So because of the methodological, technical and financial obstacles, the visibility of blue carbon in national greenhouse gases emissions reporting is currently very limited, and this is the point that I want to stress. Now because of the lot of technical, methodological and financial obstacles, the visibility of blue carbon in the national greenhouse gas, even though nations contribute NDC, they claim that, but their visibility in the these policies are very limited, and only few countries with coastal wetlands are able to report the emissions and removals at present. So this is something that needs more research and attention in this aspect. And next one, this is another important, since these blue carbon has been explicitly or defined everything, we need another important publication that I want all of you to look into, that is locking carbon in wetlands, enhancing climate action by including wetlands in NDCs. This is an important publication where they are looking beyond blue carbon, because these coastal, not just tidally influenced systems, are having a very high impact on the high mitigation potential. But there are systems like peatlands, which are very high sequestration capacity, which, as I mentioned earlier, they have, and permafrost like sort of things, they have a very significant impact on carbon sequestration and carbon burial, rather not just the tidally influenced system. That is not just beyond, we have to look beyond this blue carbon, and that is what this report is all about. So these things, when they drained and degraded, especially these peatlands, emit significant quantities of greenhouse gases, and hence proper management and wise use of these kind of peatlands and other wetland types are very much important, so that we can reverse the trend of greenhouse gas emission, and we can promote the greenhouse gas sequestration capacity. So that's very important, not only just blue carbon, but other carbon, that is other systems which are not tidally connected, are also having a very high carbon sequestration potential, and they have also should be maintained or equally maintained as tidally influenced systems like blue carbon systems that we mentioned. Next one. So these from the report is the major highlights that I want to stress is that nature-based solutions are gaining more recognition as low regret or no regret. I can say that it's not low regret; it can be a no regret and high impact means of investment, which countries can meet the ambitious targets laid down in their NDC. So they have to look for these kind of nature-based solutions, not just the cutting down that few fossil fuels or looking for renewable energy investments. So they have to invest on a nature-based solution also, apart from these kind of investments which they have already committed to meet the NDCs. So wetlands are mostly overlooked in this kind of assembly in spite of their carbon sequestration capacity and all these things. So clear guidance and good data will help parties to the UNFCCC properly value the wetlands and their capacity to reduce emissions and store carbon while simultaneously serving as integral tool in the climate adaptation strategies. So this is the most point that I want to highlight, that these kind of a clear guidance and good data is required for inclusion of these wetlands properly into the NDC schemes. That is very important, and it should be the low cost or the high impact and low regret in or no regret interventions is on the management, or the once we manage the wetlands, there will be co-benefits like climate change mitigation, and there are other co-benefits also, but here we are mostly focusing on the other the climate related co-benefits of wetland conservation or management. And these are the 4 recommendations. Wetlands are effective tools in NDC delivery, focus on key opportunities that wetlands provide by active conservation of intact wetlands, particularly across permafrost and other tropical regions, to be given priority, recognizing these landscape hold a vast volume or stores of carbon and the cost and benefits. It recommends that wetlands should be included in NDCs to ensure multiple co-benefits that it possesses, like flood, like all the disasters related to the extreme climate events, water quality improvement, biodiversity conservation. All these are there, which also partly they are significantly contributing to the climate mitigation also. So these cost benefits and everything will make wetlands a very suitable agent for these kind of a low regret, high impact investments. So next one. So another important aspect or the report that looks into these kind of aspects is the wetland inventories for wetland carbon assessments. So how much, as I mentioned earlier, there are a lot of ambiguities or clarity, methodological clarity is required. How these can be included, whatever the benefits of wetland conservation, how these kind of greenhouse gases mitigation is being happening, or the carbon sequestration is happening, it has to be meticulously measured and included in the NDC. So that aspect is having a lot of clarity lacking is there at the present time. So that is hindering the direct investments or long-term investment in the natural-based solutions when it comes to climate change mitigation or the climate funds. So wetland type, you can see that all these major wetlands like peatlands, mangroves, which are having very high potential, and if they are managed properly, they can having a very good investment for this thing. And now the data gap is very bad, very less. So that means that is that the data or the knowledge gap in that aspect is very high, and that's why there are a lot of problems in executing all these kind of investments. Next one. So IPCC, they have put forward there are guidelines for this inclusion of wetlands. So there are key aspects of IPCC guidelines related to wetlands in the greenhouse gas inventories include. Actually, they have defined what is the major greenhouse gases like methane, nitrous oxide, and carbon dioxide are the main greenhouse gases they have mentioned in this GHG estimation, and the later two, the carbon, methane and nitrous oxide are very high significance compared to carbon dioxide because of their high radiative forcing and their high potential for global warming. So, they have three tiers of estimation is now presently available. The methodology complexity is that as we go from this, you can see from the triangle that thing. As we go down from the tier 1 to tier 3, that uncertainties are being reduced, but the complexity is getting improved. So first tier approach studies provides a very default fraction without requiring any detailed specific data of the location or region, because if there is no much data available for the location or the wetlands, then you can go for tier 1 approach, where we are simply using calculating the area of that and the global average, whatever the global average default values there, we are putting in that, and we are having a very vague estimate of the greenhouse gases emission that is happening. Then tier 2 is more systematic approach, where we put in the basic data of the wetland, vegetation type, the water table depth, soil characteristics, and climate condition of the particular location is being included in this kind of estimations. And this type 2 is an intermediate level. Type 1 is a very, very vague estimate, but type 2 is an intermediate level, where we will get a more reliable or kind of a what is a regional specific data. But the tier 3 approach is the most suitable one, but that is very very complicated system, which actually very kind of a most advanced and data intensive level of greenhouse gas estimate, because where we actually sampled the location, the very closely spaced location we have to sample, and we have to continuously monitor that, and we have to directly measure the high resolution, high specific data we have to measure, and even that direct flux measurements we have to take, and which will be actually supplementing the greenhouse gas estimate in the system. But the system is, that approach is very complicated and very tiresome, but that will give you a very reliable estimate of the greenhouse gases emission that is happening from a wetland system. So these are the three tiers of methodology and their complexity variations also. Next one. And when it comes to the global peatland extras, we can see that peatlands are having very high amount of carbon storage, as I mentioned earlier, and their conservation is very, very important when it comes to climate change mitigation, because and you can see that there is a this global peatland hotspot atlas will give you a indication about the global areas where how much of these peatlands are being estimated. And India, we can see that there is a recent estimation of the report, that is peatlands of India, an overview of the future overview and the future roadmap, where the government is trying to restore or manage the peatlands for the climate change reversal or climate mitigation strategies that is highlighted. And we have 4 major zones where peatlands have been estimated, which it comes to around more than 30 lakh hectares of peatlands are available, means are being mapped in India, and the more recent mapping and other things are being carried out, is underway only, which is not being completely done. Next one. So based on all these basic background, but we are currently working from CWRD. We are working. We are trying to have an inventory of greenhouse emission from the important coastal wetlands of Kerala, because as I mentioned earlier, there are very huge data and knowledge gaps are there, and how they are going to be means supplemented in this. NDCs are also not being very much certain, but still we have initiated this thing, that inventory of greenhouse gases emission and their seasonal changes, and what are the major factors that is modulating the greenhouse gases emission from these wetlands. I'll quickly wind up in 10 minutes. We have selected 5 major coastal wetlands of Kerala, and we are working on the greenhouse gases flux estimation in these areas. Next one. And we have seen that, and I've just chosen one of these wetland, that is Kadalundi, which is a community reserve in one of the important community reserve in Kerala. And we have it's last 1998 to 2022, there is a drastic change in the LULC, because as I mentioned earlier, the major threats to this wetland is the changes in the LULC because of the high population density and urbanization pressure. The wetlands are being converted to not wetland uses. So that is the major issues that is actually triggering the greenhouse gas emission also. So there we can see that the build-up area has been significantly means it almost now doubled, and that means rapid urbanization is happening in this particular study area where I've done my preliminary studies. Next one. And this will be a case for every wetland. It's not just specific for this particular wetland I am addressing. It will be a common phenomena for all the wetlands around India also. So there this is the way where we can measure the above and below ground biomass. Then the left we can see a standard operating procedure for the wetland carbon estimation is there, where you just go through these things, how the wetland carbon is getting estimated, that I'm not detailing here. Next one. We have to go for the core rise, and then from the core we have identified how much carbon is there in all the layers. And next one. And finally, we have found out how much of total biomass is being stored and how much of carbon stock is there for different species of mangroves also, because these mangroves are actually having a very high potential for the carbon sequestration as well as carbon burial, as I mentioned earlier, because it's a blue carbon system. Next one. And apart from even though these, as I mentioned, there will be these wetlands can also as an emission of greenhouse gas, as a source of greenhouse gases emission also. So these greenhouse gas emission also we have estimated from these wetland, major methane, carbon dioxide and nitrous oxide emission is there. But when it compared to the other wetlands around the tropical wetlands around the country or in other areas, tropical areas, the amount of carbon dioxide, methane and nitrous oxide emission are very, very less. But still there is significant means emissions are there from the wetland. Next one. So finally, there is that next one. I'm not going to the other details of this thing. So this is that sediment core. These sediments core analysis show that these wetland act as a large reservoir, about 694 to 100 tons of carbon per hectare, mostly concentrated in the upper soil layers. And these Avicennia, these mangrove species are having 70 to 75 biomass carbon due to high density and large stem diameter. That is particularly for this thing, with 66% of carbon stored in soils and a large carbon stock. Compared to the regional averages, this Kadalundi wetland offers a significant potential for climate change mitigation through carbon sequestration. So this is the way how we can estimate the carbon storage. And even though we can see that supersaturation of nitrous oxide, methane and nitrous oxide, methane and carbon dioxide is there, and because of this high microbial activity and all, because in spite of that low gas emissions, the Kadalundi wetland actually function as a net carbon sink due to high carbon retention and in biomass as well as soil. So next one. And so that means that it has to be maintained, or that the wetland has to be managed properly. And there are in India we have regulatory framework for wetlands, specifically for wetland. Next one. There are a lot of major thing is that the Umbrella Act of UN, that Environment Protection Act, and after that we have been this is the main thing that I have divided, that Wetland Conservation and Management Rules 2017. With the implementation of these that paved way for the establishment of state wetland authorities. Now the state, each wetland each states and union territory has its own wetland authorities which are maintaining or managing the conservation and the knowledge dissemination and other activities in wetlands, which is a very significant step towards the management of wetlands in India. There are these presently, the wetlands of international importance and wetlands which are being notified as wetlands as per the wetland conservation and management rules will come under the purview of these wetland conservation management rules. But the problem is that even though we have 96 wetlands which are of Ramsar importance as well, and there are only few wetlands apart from that is being notified as per the wetland conservation and management rules. That is the problem. We have 2.2 lakhs, as I mentioned, 2 lakh and 2,205 wetlands which are being identified as per the National Wetland Atlas. Only 100 or less than 150 are being regulated under this prevention of these rules, because there are a lot of procedural barriers are there to declare these wetlands as wetlands as per this wetland management rules. Then only these rules will be implemented, and the prohibitory and actions that is there, the construct, because there, as per the just like CRZ, there are a lot of activities which are being prohibited under these rules are there, which will be implemented once it is being declared as a Ramsar site. So that is declared as a notified wetland. Next one, we have this Ramsar also, because we have 96 wetlands so far being declared as a Ramsar site. From 90, India became a signatory in 1981. Actually, 81, we have declared two wetlands into Ramsar, and there are a lot of stories behind how this Kailagato National Park is now in the Montreux record, and also there are a lot of problems associated with or challenges are there rather in properly managing the wetlands. For a wetland to be declared as a Ramsar site, there are 9 important criteria, and I'm not going into details about that. So that means every wetland cannot be declared as a Ramsar site. It needs one of the either one or two of these important 9 criteria to be meet to make it as a Ramsar sites for the conservation and all. Next one. And NPC, that the governing guidelines for this is the NPCA, National Plan for Conservation of Aquatic Ecosystem, which actually start with the brief document preparation, where we have a base like rapid, because I'm talking about the 2 lakh wetlands that we have here, and many of the wetlands will not have any of the data that is available for conservation. So for that, we first need to prepare a brief document about the rapid baseline data collection to determine the extent of wetlands, the characteristics, and the key biodiversity and other services the wetland record. Then we have to go for a wetland health card preparation for that particular wetland based on 5 major categories. I will come to that. Then we have to include that we have to make the services of wetland mitras and other networks, social networks, so that these wetlands are being managed with the proper association of these citizens and other people. And then finally there is an integrated management plan that is getting prepared for the wetlands. Next one. So this is about a brief document. We have to start with a brief document about all the data that is available for the wetland. This is the first step of wetland, and everything is available in the State Wetland Authority website. So kindly go through one of these particular brief documents to get a brief idea about how these brief documents are being prepared. So that is an important step for the initial step for the conservation of a wetland. Next one. Next one is the health card preparation. We'll make the health card, because if the rank is 0.5961 is a very good rank, and below that, if it is having a very A+2 E category is there, then next slide I will explain. This is based on 5 categories like area, which are how much of area of wetland is converted to not wetland uses since 2000. Then hydrology and catchments, how much of that how many inlets or outlets are there for the wetland, and how many of these are choked or natural. So that will itself signifies the health of the wetland, hydrology and catchment. Then water quality, pH, dissolved oxygen, and biological oxygen demand. These are the three parameters that is being highlighted or being utilized to identify the water quality. Then biodiversity, how much of invasive species are there, how much of water birds are being coming there or sighting are being sighted there. And the governance, like how many, if the wetland is having a clearly demarcated map or management action plan is there, or wetland is being notified. These are the major 11 parameters which we will take gives us an indication of the wetland health. And for the Ashtamudi wetland, it is 0.96 because of most of the criteria has met. That means it's a very important wetland. But most of the cases, the governance aspect and most of these parameters are not being known for most of the wetlands. So that is a main problem that is hindering the management of these wetlands in India. Next one. So these are the major. If you plan a wetland management, it looks by cross-sectoral integration of all the sectors. That is not just to one sector is there. There are multiple stakeholders are there. All the stakeholders synergizing all the stakeholders will be required, and there should not be wise use, because it should not be exploited by a particular stakeholder, and it should be wise used in a wise use concept, and its management is to be holistic. Not that that entire wetland needs to be managed. There is a zone of influence or the catchment area of the wetland. That means integrated management of the entire wetland zone of influence is to be taken care in the management action plans. Next one. Next one, please. So this is the freely available in the website. That is for webinar called Wetland. There are 8 chapters in that. One is about the goal and purpose of the particular management plan. Then wetland, complete description of the wetland, how the wetland behaves, what is the ecological character, that is wetland evaluation. Then there is a management framework, it is there. Then it has to be monitored regularly. That's a monitoring plan is to prepare, and we have to prepare the action plans for the management of the wetlands. Then budgeting and review adaptation. There are 8 chapters which is being means specified in the NPCA, National Plan for Conservation of Wetlands. So kindly go through these kind of NPCA guidelines, as well as the publication that is available in the wetland portal of MOEF and CC. That, as I mentioned in the beginning slide itself, it will give a lot of information about how the wetlands are being managed. Then this is another aspect, integrated inventory assessment of management of the wetlands, which are being carried out via, it is called the VAMs, which will give us a better idea about the nature of the wetland, where there will be any changes in the wetland character, how we can prioritize the intervention or management. Next one. Any of details of all this, and there is an VAMs portal for Kerala is available, where you will get a real-time data about the wetlands and their all the quality, water quality, and sediment quality data also. If you want any of these information, you are free to approach me directly. My email ID and everything will be available with these organizers, and you can directly contact me for any further clarification in all these things. Next one. Next one, there is it's very important to have a capacity building program. In that, we have done a lot of trainings and research, because as I mentioned earlier, there are a lot of gaps in research and knowledge gaps are there. To bridge that things, we have arranged a lot of next slides. A lot of capacity building programs. Next one. So we are currently doing next one. We are currently doing this kind of capacity building for Kerala through different kind of conservation kind of trainings and workshops being arranged constantly for these target groups, so that they get a better idea about the conservation and management of wetlands. Next one. And Wetland Day also. Wetland Day national every year. in the February 2nd, there is a wetland day, which also promotes the wise use of wetlands, conservation and wise use of wetland. Each year they will have different themes, and I just want everyone to just go through this next year theme and just contribute towards that thing. Next one. This is how we celebrate the Wetlands Day. Last year we have how we celebrated. You can skip that. Then there are another one is called next one. Next one. This is wetland mitra enrollment. It's very important that we build a citizen knowledge base or citizen workforce for the conservation of wetlands. So we have enrolled many students, many NGOs and everything for the wetland as wetland mitras. Next one. And this is one of the major aspects. I'm not going into details about all these things because of the time constraint. It is the NPC, a national plan for national CPS. CPS stands for communication, education, participation and awareness strategy for wetlands in India. It is available in our national means wetland portal of India, where we will get a lot of idea about how the wetland conservation and management has to be made with the support of the workforce or citizen science initiatives. Next one. Next one. So this is one of the important aspects, and I request all of the people who are here, who have never heard of this wetland mitra concept, just try to enroll as a volunteer of wetlands, and you can manage the wetlands or at your area, because it gives you a ownership, a profound ownership of the wetlands, where you can actually contribute towards the management of wetlands in a very systematic way, and all the databases that you provide will be stored in the our website of the state wetland, means wetland authority websites, and which will be useful for the wise use and conservation of wetlands. Next one. And this is the major next one. I'm not going into details about these things. CPA strategies. Next one. This is how the communities near wetlands, how we can be a part of the initiative to support the wetland management. Like communities near wetlands, they can develop knowledge-based education materials, create biodiversity murals, support cleaner drives. Farmers, even industry farmers can have a sustainable agriculture practices, and eco-development communities, schools and students, the women and wetland conservation. So many aspects are there. Tourism, how they can promote the eco-friendly tourism and other things, and by which way they can have indicative actions for major stakeholders groups. So this is a very indicative action that I have put forward. It is also available in the CPA strategy, where everyone can go through and have a kind of contribute towards the land management. Next one. And this is the last slide. Guidance for there is an institutional framework where we can say that there is a wetland division of our MOEF and CC is there, which is contributing the CPS and the other strategies for wetland conservation, and state wetland authorities are there, which are actually implementing this on the ground level. And there are other stakeholder departments like the Department of Fisheries, which promote sustainable fishing activities. Agriculture departments are there, which are also contributing towards the management, because it cannot be, because it's a stakeholder interactions are there in the kind of wetlands, and it cannot be managed by a single authority. It has to be a kind of a combined effort, and this is a guideline developed for the CEPA strategy for the implementation of the wetland wise use. Next one. And this is the last slide that I said. So integrating wetlands into climate action, there are now barriers is that wetland carbon is under research topic in India. Wetland greenhouse gases inventories have been taken up for a few wetlands only. Peatlands and permafrost have not been completely mapped. Then there is a policy level where wetlands are not having a very significant participation or space in the climate policy, and there are limited and systematic consideration of wetlands in the state action plans of climate change also. then in the practice also limited projections on climate storage in wetlands, and if there is a like if we want to invest on the wetland, how much tenure can we want to, or how much there are a lot of ambiguities about how to invest on wetlands also. That are the major problems that is has to be integrated so that India can achieve the greenhouse gas emission target they have means as per the Paris Agreement they have mentioned. So that is India's 15.3 billion wetlands have a very major role in maintaining or to in our NDC, achieving our NDC. But there are a lot of ways to go beyond for that also. So next one, thank you. So restoring lost wetlands is very much vital for the reducing the cost of climate change disasters. So with that, I'm just stopping with that. I know that most of the things I have read, and many of these I'm not able to explain within the stipulated time I have given, but you are free to approach me at any time, and I'll be happy to share all of the information or all the documents that I have with me. And most of the, and I also request every one of you to go to the resources library of these state means wetland portal of India, where you will get a lot of information about the policies, the wetland, their significance in the climate change mitigation. Thank you.
Thank you, sir. It was very informative presentation. Now the floor is open for questions. Participants can, if you are having any questions, the speaker is ready to answer.
As I mentioned, you can email me also if because I know that most of the things I've read. So if you have any other doubts related to the greenhouse gas estimation or the research areas where we are actually actively working on, so you can email me. My email ID is there in the presentation also, so you can approach me at any time through email. I'll be happy to answer your questions and queries.
Puducherry Climate Change Cell website.
Okay.
We are regularly hosting all the presentations in the Climate Change Cell websites.
Okay.
And also in the YouTube, the recorded video will be available.
Okay, fine. So that they can refer it at any time also.
At the college levels, sir.
Yeah.
Any conferences also like.
Yeah. That's what I initially mentioned as I have a. What I initially mentioned as I have a project on the integrated wetland inventory assessment and monitoring system. So in that, actually, what I did was I encouraged the students to participate. I've arranged a national conference exclusively for the researchers who are working in the wetland related all the aspects, like from hydrology to climate change. All their major topics were discussed in the conference for 3 days, and these students were actually given free of cost there was no free of cost there was no registration charges, and even there was no other charges for their stay and other accommodation. So we have arranged that thing, and we have actually doing all these things arranged that thing, and we have actually doing all these things in for capacity building in the Kerala state. For Puducherry, if it is if you are in that place, SACON is doing a lot of these kind of activities on capacity building and these kind of activities that Puducherry that wetland authority. So
yes.
They will be, and many courses are there in the online platform. Resources materials are there for all the basic information for understanding the basic information on the wetland conservation and management. There are 7 to 8 modules are there about wetland.
Okay.
So that is available in the online platform in the Wetland Authority, and also there are online courses also there in that.
Okay.
So that will be a basic step for students to learn the basics of wetland conservation and management aspects, and then finally they can build on the things. So that is one option you have got, and otherwise also there will be, because we are actually Ministry of Environment, Forest and Wildlife doing a lot of these kind of capacity building programs and awareness program for students and also. So that when you, if you refer to that website, you'll get a more information about the activities that will be happening related to these things. So that will be an added event. And even the State Wetland Authority website also will be a very good.
Yes, yes. Okay. Okay. Thank you so much, sir. Thank you for your enlightened talk, sir.
Thank you. Thank you.
Sir, so we'll move on to the last session. I now request Santa Lakshmi, Senior Project Associate of Puducherry Climate Change Cell, to deliver the vote of thanks for this webinar.
Good evening to all. On behalf of the Puducherry Climate Change Cell, Department of Science, Technology and Environment, I extend my sincere gratitude to everyone who joined today's webinar on building wetland resilience and mitigation. I express my heartfelt thanks to Dr. Ranjit K.R., Scientist B, Ecology and Environment Research Group, Center for Water Resources Development and Management, for his highly insightful and scientifically rich presentation. His comprehensive explanation of wetlands as carbon sinks, blue carbon ecosystems and their role in climate mitigation, disaster risk reduction, and biodiversity conservation provided valuable clarity. The case studies, data-driven findings, and emphasis on wetland restoration, health assessment, and community participation were particularly enlightening and relevant for regional climate action planning. Thank you, sir. And I thank Thiru K. Kalamegam, Environmental Engineer, Department of Science, Technology, Environment, for delivering his opening remarks and highlighted the importance of integrating wetland conservation into climate and development policies. Our special thanks to the Director, Department of Science, Technology and Environment, for her constant guidance, encouragement and supporting in organizing this important knowledge sharing initiative, engagement and thoughtful interaction. Thank you, sir.
Thank you, sir. We are winding up.